Download this code from codegive.com, link in the description below. Probabilistic programming is a powerful paradigm that allows developers to define probabilistic models using code. It enables the representation of uncertainty in complex systems and facilitates inference about latent variables from observed data. In this tutorial, we will cover the basics of probabilistic programming, its applications, and provide some code examples. What is probabilistic programming? Probabilistic programming combines traditional programming with statistical modeling. It allows the user to specify a probabilistic model in a programming language, and then perform inference, i.e., make predictions or estimates, based on that model. This is particularly useful for handling uncertainty in real-world data. Key concepts. 1. Probabilistic models. These models describe a system using random variables. For example, in a weather model, the probability of rain might depend on various factors such as temperature and humidity. 2. Inference. The process of deriving conclusions from a probabilistic model. This often involves calculating the posterior distribution of unknown variables given observed data. 3. Latent variables, variables that are not directly observed but are inferred from the model. For example, in a topic modeling scenario, the topics are latent variables inferred from a collection of documents. 4. Bayesian inference, a common approach in probabilistic programming where Bayes' theorem is used to update the probability estimate for a hypothesis as more evidence becomes available. Real-world applications. Machine learning, probabilistic models are used to make predictions based on uncertain data. Natural language processing, topic models and language models often employ probabilistic methods. Robotics, used for sensor fusion and decision-making under uncertainty. Finance, risk assessment and modeling of market behaviors. Popular libraries. 1. PyMC3, a Python library for Bayesian statistical modeling and probabilistic machine learning. 2. TensorFlow Probability, a library for probabilistic reasoning and statistical analysis in TensorFlow. 3. Stan, a platform for statistical modeling and high-performance statistical computation. Example, Bayesian linear regression with PyMC3. Let's walk through a simple example of Bayesian linear regression using PyMC3. This example will illustrate how to model a linear relationship with uncertainty. Step 1. Install PyMC3. Make sure you have PyMC3 installed. You can install it via pip. Step 2. Create synthetic data. We'll create some synthetic data that follows a linear relationship with noise. Step 3. Define the model. Next, we will define a Bayesian linear regression model using PyMC3. Step 4. Analyze the results. After performing the sampling, we can analyze the results to understand the posterior distributions of our parameters. Step 5. Make predictions. We can use the posterior samples to make predictions. Conclusion. Probabilistic programming provides a powerful way to model uncertainty and make inferences based on observed data. In this tutorial, we covered the basics of probabilistic programming, its applications, and walked through an example of Bayesian linear regression using PyMC3. By leveraging these tools, you can build models that account for uncertainty in various real-world scenarios. Feel free to explore the PyMC3 documentation for more advanced features and techniques.